are the step-by-step instructions for performing a most interesting experiment highlighting the concept of osmosis. For a simulation of diffusion, go to the Explore Learning gizmo on diffusion. For a simulation of osmosis, go to the Explore Learning gizmo on osmosis. An egg and a few household chemicals are all you need. Weigh your raw egg in grams. Measure 250 milliliters of vinegar. Pour into a clear cup. Gently immerse your egg. Notice the bubbles. What could the gas be? Notice the egg begin to rise. Leave it overnight. Watch the egg rotate. Can you explain why it continues to rotate all night long? Lots of gas. Pour off the vinegar. Gently peel off the shell, which is no longer rigid. Weigh the egg without the shell. What happened to the mass of the egg? How do we explain it? Measure out 250 milliliters of corn syrup. Pour into a clear cup. Immerse the egg minus its shell. I wonder why it floats so high. Let it sit overnight. Next day, wow, it shrank. Remove it from the corn syrup. What happened? It looks deflated. Weigh it. Wow, it weighs so much less. Pour out the corn syrup. Notice there appears to be two layers, one thick on the bottom, one thin on the top. What is the explanation? Weird looking. Measure out 250 milliliters of distilled water. Pour it into your cup. Immerse your shriveled egg. Whoa, the egg bloats up. And it gained lots of mass. It definitely got bigger.
It's a bouncing eggy.
Bouncing egg.
Since it got all the water in it and the membrane is also really tough, it got really tough and thick, so now it can bounce.
That's right, no shell either.
I'm playing basketball, woo! Woo!
We are going to investigate two Explore Learning gizmos, one on diffusion and one on osmosis. Both processes were occurring in our egg. Diffusion is the process by which particles in an area of high concentration, by purely random movement, travel to a region of low concentration. The process continues until both regions have the same concentration of particles. There are two regions, A and B. In this simulation, region A begins with 50 particles, region B, 0 particles. Through just random bouncing around, particles in region A gradually drift over to region B. Eventually, there is an average of 25 particles in each region, remaining that way even as the particles continue to bounce around. At this point, we say the concentration of particles in region A equals the concentration of region B. In this bar chart, we see initially particle X is concentrated entirely in region A. But as we start the simulation, the particles migrate over through the process of diffusion to region B. until the concentrations of particle X in region A and region B are equal. Notice that the concentrations continue to fluctuate but remain essentially equal. This Explore Learning gizmo simulates the process of osmosis in our egg. Here's our egg represented by a darker pink inner square placed in corn syrup represented by the surrounding lighter pink square. The small green spheres represent water molecules. The larger purple spheres represent sugar molecules. The membrane around the egg, represented by the edge of the inner square, is semi-permeable. The membrane allows water molecules to pass through, but not sugar molecules, which are too large. The concentration of sugar molecules in the corn syrup surrounding the egg is higher than the concentration of sugar molecules inside the egg. In the simulation, the water molecules inside the egg flow out of the egg through the semi-permeable membrane into the surrounding corn syrup. This is called osmosis. As this happens, the egg shrinks. Watch how the water molecules leave the egg. Notice that the sugar molecules are unable to cross the semi-permeable membrane. Next to our simulation, you see two bar charts. The bar chart on the left shows how the beginning concentration of sugar molecules is much higher in the corn syrup surrounding the egg than inside the egg. The bar chart on the right shows how the volume of the egg changes as it floats in the corn syrup. Notice that the egg shrinks as the concentration of sugar molecules equalizes between the inside and the outside of the egg. This graph shows how the concentration of sugar molecules between the inside and outside of the egg become equal as the water leaves the egg. In this simulation, we see the egg placed in distilled water. Here, the concentration of sugar inside the egg is greater than the concentration of sugar outside the egg. Before, when the egg was placed in corn syrup, water molecules left the egg, causing the egg to shrivel. Now, water molecules are entering the cell, causing it to swell. This bar chart records how the initially higher concentration of sugar inside the egg equalizes with the lower concentration of distilled water. As this happens, the egg swells in volume. This graph captures the movement of water from the distilled water surrounding the egg into the egg, lowering the concentration of sugar inside the egg. Corn syrup is called a hypertonic solution. The egg shrinks in corn syrup. The egg shrinks in hypertonic solution. Distilled water, on the other hand, is considered a hypotonic solution. The egg swells in distilled water.